Okay, 3.9 is about inverse trig functions and their derivatives. And before we get started, I want to do a real short review of inverse trig functions and how they work. So let's just work with the sine function right away. So let's say you have y equals the sine of x. Well, the inverse function is sine inverse of y equals x. Those are the same relationships. And so into the sine function, we get to put angles, right? We put angles in, and what do we get out? We get out ratios. Ratios of side lengths. So I'm just going to call that ratios. And so into the inverse function, what goes in is a ratio of side lengths. And what pops out is an angle, right? So we always need to keep in our head, like, what is the variable representing? Is it representing an angle? Is it representing a ratio? What is it? That'll help us keep track of a lot of things with these inverse functions for sines and cosines and tangents and stuff. Okay, so another quick thing I want to do, if I tell you to take the sine of the cosine inverse of, say, x, what should we do to write down what that expression is algebraically? Well, okay, this x value is going into an inverse function, so it is a ratio of sides, right? Okay, so that means that there's a triangle associated to it where the cosine is equal to that ratio. And the cosine, let's put in a theta here, the cosine is the adjacent over the hypotenuse, so this ratio should be x over 1. And that makes this side 1 minus x squared under a square root using the Pythagorean theorem, right? And so if I want to take the sine of this angle theta here, which is my cosine inverse of x, right? The cosine inverse is the angle, which gives me x as the ratio of adjacent over hypotenuse. So I've drawn the triangle, put in the angle where the adjacent side over the hypotenuse side is x. And so if I take the sine of that angle, I will get the opposite side over the adjacent side. So the opposite side, opposite side over the hypotenuse, the opposite side is 1 minus the square root of x. 1 minus x squared all under a square root. And then the hypotenuse is 1, so this is the square root of 1 minus x squared. That's the sine of the cosine inverse of x. We can do that with other functions too. Let's say I wanted the tangent of the cosecant inverse of say x minus 1 over x plus 1. Okay, so what can I do? Well, I've got the cosecant as the ratio that I'm looking at this time, so I'm still going to draw a triangle. I'll still put in theta there. The cosecant is the inverse of the sine, so that's the hypotenuse over the opposite. So the hypotenuse over the opposite makes x minus 1 the hypotenuse, x plus 1 the opposite, and then I use the Pythagorean theorem to figure out what this side is, right? So I know that x minus 1 squared equals x plus 1 squared plus the adjacent squared, right? I don't know what a is yet, but I can figure out what a is in terms of these guys. So I've got x squared minus 2x plus 1 equals x squared plus 2x plus 1 plus a squared. So a, these will cancel, those will cancel. I get minus 2x, minus 4x when I move everything over. And I'm going to take a square root, so x had better be negative in this case for this thing to work out for me. But this is going to be the square root of negative 4x. And so the tangent, which is going to be opposite over adjacent, is going to be x plus 1 over the square root of negative 4x. and we're hoping that the x value is going to be a negative. And it can't be, well, it can be 2 negative. Yeah, that's fine. Okay, so there's what we've got for that one. But we draw the picture of the triangle, and then we figure out what the ratios do. Okay, let's do some differentiation now. So let's try and take the derivative of, let's go sine inverse first, sine inverse of x. Okay, we're going to use implicit differentiation. We're going to write this as y equals sine inverse of x, which translates to the sine of y is equal to x. And then we use implicit differentiation. We're going to try and get y prime. And so I take the derivative of the left-hand side, and I get the cosine of y times y prime is equal to 1 when I take the derivative of the right-hand side. So y prime is equal to 1 divided by the cosine of y, which is equal to 1 divided by the cosine of the sine inverse of x. And this is why I had us doing that sort of draw the triangle type thing earlier, is because now I'm trying to find the cosine of the sine inverse of x. So let's draw the triangle that's associated with that. Here's theta. That's the angle, the sine inverse of x. The sine inverse of x over 1. Sine is opposite over hypotenuse. So we put the x there. And now this side is 1 minus x squared under a square root. So y prime equals 1 over the cosine is the adjacent side over the hypotenuse, 1 minus x squared. Okay, so there is your derivative of the sine inverse of x. So derivative sine inverse of x equals 1 over the square root of 1 minus x squared. Tangent squared, cosine squared, all that stuff comes about in a similar manner. Let's just write them down. Derivative of the tangent inverse is 1 over 1 plus x squared. Derivative of the secant inverse is equal to, I think I've got an absolute value in there. Yep, I've got 1 over absolute value of x and the square root of x squared minus 1. Okay. So for some of these, you can notice that the domain is going to have to be restricted, right? On this, I don't want to take square roots of negative numbers, so I need that the absolute value of x is less than or equal to, is strictly less than 1. I can't be equal to 1 either, otherwise I'll be dividing by 0. Okay, so I need that my ratio is less than 1 there. Here, I don't have any restrictions. I don't have anything, no problems with that guy. With the secant, I need not to be dividing by 0 again, so I need that the absolute value of x is bigger than 1, otherwise I'll be dividing by a negative, right? And if I put in next that's less than 1 in there, and I take away 1, I'll have a negative, so I need the absolute value of x to be bigger than 1 for this one. So there's my domains. Okay, that gives you sine, tangent, and secant. There's another little trig trick that lets us have the other ones. Okay, so let's think about it a little bit. So cosine inverse of x, and we're going to compare that to sine inverse of x. Okay, so let's draw the triangle that has x on one of the sides and 1 here. Okay, so if I put theta here, that's going to be the cosine, that's going to be the sine inverse of x. That's the angle. If I take the sine of this angle, it gets me to x, right? So this sine is sine inverse of x. This angle here, I'm going to call it not theta, but let's call it tau. This angle here would be the angle that gives me a cosine inverse, a cosine of x. So this is the cosine inverse of x, right? the ratio in this triangle of x, you can either get it from the sine of this angle, or you can get it from the cosine of this angle. And because that's true, what happens here is the cosine inverse is pi over 2 minus the sine inverse, right? These are angles, and the angles in a triangle have to add up to 180 degrees, right? So this one, they're complementary angles here. 90 minus this angle would give me this angle. Similarly, 90 minus the cosine inverse would give me the sine inverse. So there's this relationship between cosine inverse and sine inverse. Similar relationships hold between, let's go with cotangent inverse of x is equal to pi over 2 minus tangent inverse of x. These are complementary angle identities, and then cosecant inverse of x is equal to pi over 2 minus secant inverse of x. And it's the same idea. If you draw the triangle, the complementary angle gives you the other angle, which has that same ratio. Okay? And so if I'm wanting to find the derivative of the cosine inverse, I'm going to take the derivative in this sense, which just adds a minus sign to my derivative up here. Same thing for all of these. So the sine inverse and the cosine inverse are negatives. The derivative of the sine inverse and the derivative of the cosine inverse are negatives of each other. The derivative of the tangent inverse and the derivative of the cotangent inverse are negatives of each other. The derivative of the secant and the derivative of the cosecant inverse are negatives of each other. So let's write those down. The derivative of cosine inverse of x is equal to negative 1 over the square root of 1 minus x squared. The derivative of the cotangent of x inverse is equal to negative 1 over 1 plus x squared. And the derivative of the cosecant inverse of x is equal to negative 1 over absolute value of x square root of x squared minus 1. So they're the negatives of the ones that we originally had, and that's because they're complementary angle identities. That pi over 2 minus the cosine inverse is equal to the sine inverse ideas. Okay, and now that we have these basic ones formulated, you just get to use your quotient rules, your product rules, your chain rules, and all of that stuff now with these new identities. And maybe there's some trig involved, so remember to practice your trig, and we'll go from there.